Hi everyone, welcome back to another video where today we'll be discussing vaccines. For this video I actually rotated my presentation to be horizontal instead of vertical, so let me know if you guys like that better. The topics that we will be discussing today are the basics of the immune system, how vaccines work, and any risks involved in getting them. Okay, so let's get started with the immune system. The primary goal of the immune system is to get rid of pathogens, which is a fancy way of saying germs, and store the memory of how to get rid of that exact same pathogen in the future. Now, something you may have heard someone say before is that if you have a fever or any sort of symptoms, that means that it's working, which is true. A fever is part of your innate immunity, meaning that it's not specific to any sort of pathogen. Another type of innate immunity is inflammation. And you may recognize that when a part of you becomes inflamed, that part becomes a lot warmer. And this is because your body is heating up that spot where the pathogen is in order to try to kill it. The opposite of your innate immunity is your acquired immunity, and this is specific to certain pathogens and certain strains of pathogens. Now, what I mean by this is that pathogens can mutate, meaning that it will change, and the way that you fight them is going to have to change in response. When you have pathogens that mutate really quickly, you'll have to create new vaccines for them really often. For instance, the flu. You have to get a new flu vaccine every single year because of how fast the influenza virus mutates. A big part of your acquired immunity is lymphocytes, which you may know as white blood cells. Two of the lymphocytes we're going to look at today are T cells and B cells, and they each have their own unique properties. For instance, some T cells can actually kill the pathogen, and some B cells can store memory on how to kill the pathogen, which will be used if you ever come in contact with that pathogen again. So let's look at how this actually works. Let's say this pink star-shaped thing that kind of looks like Patrick from SpongeBob is the virus. And on the left, we have our macrophage, which is just a big white blood cell. The white blood cell will consume the virus in a process called phagocytosis. And from there, it dissolves the virus and breaks it down into little parts, where it will acquire its antigens. The white blood cell also contains these things called major histocompatibility proteins, or MHCs, which help the white blood cell present the antigens to T cells. So here's what a white blood cell would then look like presenting the antigens and the MHCs. Now that we have this infected antigen-presenting cell, a helper T cell will come along and use its antibody to bind to the antigen of the pathogen. But this antibody on the T cell will have to bind exactly to both the pathogen's antigen and the MHCs. Once they bind, a process known as T cell proliferation begins, where the T cell will then reproduce and create other cells like it. The different types of T cells that can become through differentiation are cytotoxic, also known as killer T cells. These are the ones I was talking about earlier when I said certain types can kill the pathogen. Suppressor T cells and helper T cells. Helper T cells can generate antibodies and they can activate the memory B cells. So this is where B cells come in. And B cells are interesting because they can actually bind directly to the pathogen antigen. They have no need for the antigen-presenting cells. Upon binding, this begins B cell proliferation, where the B cell can either produce plasma cells, which generate antibodies specific to this antigen, or memory B cells, which remember the type of antibody needed to bind to this antigen and get rid of this pathogen strain. So now that we have a general idea about how the immune system works, we can dive into how vaccines work and talk a little bit more in depth about them. So we'll be discussing 4 different types of vaccines today, beginning with a live vaccine. Live vaccines are created by using a weakened version of the pathogen. And while it makes your body work a little bit harder, it actually generates more of an immune response. The only downside is it's pretty difficult to make, and because it makes your body work so hard, people that have already weakened immune systems can't get this vaccine. Now moving on to the inactive vaccine. This is a vaccine where the patient has been given the pathogen that has already been killed. Then the immune system will then learn how to fight off this pathogen. The only problem with this one is that the immunity is not long-lasting. Now we'll talk about the subunit vaccine. It's made using only the pathogen's antigen, because that's all that's really needed to still trigger an immune response. Then finally, there's the DNA vaccine. This is where genes that code for the antigen have been isolated and are administered to the patient through a vaccine. This, however, has not yet been approved for human use. But what do all these vaccines have in common? Their purpose is to trigger the immune response, including generating memory cells, so that if the patient is ever exposed to the pathogen in the future, their body already knows how to fight it off. The vaccine also won't develop into the disease, which is a great benefit because your body is prepared to defend against this specific strain without you having to actually get it in order to have these memory cells. Finally, let's discuss the risks of getting vaccinated. First, there's the risk of side effects from the vaccine. Although they tend to be really uncommon, and typically are a lot more treatable than the disease itself. It's much harder to find evidence of side effects resulting in death than the disease resulting in death. Then there's the rumor that vaccines cause autism. However, this came from a singular source that was disproven many, many times. So it's safe to conclude that vaccines do not cause autism. Finally, there's the risk of being allergic to a vaccine, which is a very real risk. But if you are allergic and can't get vaccinated, this means that you have to convince everyone around you to get vaccinated. This will cause a thing called herd immunity, where if enough people in a population are immune, this will prevent the spread of the disease. Studies show that in order for herd immunity to be effective, around 95% of the population has to be immune. That's why it's so important to get vaccinated, not just for yourself, but for the people around you that can't. And now I'm bringing back the end of the video summary. So, to summarize, today we talked about the immune system and how it works, and how vaccines will then use what's built into the immune system to protect us from specific pathogens. And then finally we talked about the risks and how it's important to get vaccinated because the benefits will always outweigh the risks. And as always, thank you so much for watching. I'll see you guys in the next video. Bye!